Hey everyone, this is Ashwin and welcome back to the next installment in the design pattern series. Alright, so previously we worked on the basic implementation of a singleton, and we discussed how we have done the eager initialization, and what we want to do is a lazy initialization so that we only create the instance of this class when it is accessed for the first time. Let's go ahead and quickly do that. Now what I can do is I can just make a new copy of the basic singleton. So I'll make a copy of it and I'll paste it in here itself, and I'll call it lazy init singleton. Oops, I think I called it singletib. Let's just rename that to lazy initialize. Where is it? Oh, there it is. Rename that to singleton. Now what we have here is an exact replica of the basic singleton. We'll make it lazily initialized. So what we can say is if the instance equals null, we want instance equals new lazy init singleton. So there we have it. Now the reason this is not working is because we have our instance as final, which means that we got to get rid of that, because final means you can't update it, and you can get rid of that as well. And what have I called it? Lazy init singleton. Lazy init singleton. Where's the problem here? Oh wow, I've called it lazy lazi. Silly me. Alright, sorry about that. Let's just correct that. So there we go. That's our lazily initialized singleton, right? And I'm not going to test this because it'll work the same way essentially as our eagerly initialized singleton did. The only difference is that the instance will be made when the get instance is called for the first time. So now we have something that is lazily initialized. But there are still some problems, because let's look at it in this context. Let's say our application is multi-threaded, meaning that there are concurrent copies of our application that is making use of this singleton at the same time. So what happens then is that, let's say what we call them are threads. And what happens is, let's say one thread goes in, and I'll probably put this on a new line. So let's say there are two threads, thread 1 and thread 2, and thread 1 goes in and it's trying to get the instance. Now thread 1 goes in and checks if the instance is null. The first time the instance, because it doesn't have a value, it is null. So the thread decides, yes, it's good to go inside. It'll go over to line number 11 and it'll stop here, and now it lets go of the CPU, and another thread takes over, and that checks if the instance is equal to null. And in that case, because this line hasn't been run yet by thread 1, thread 2 gets inside, and even that is able to access this instance and make a new lazy init singleton. So that's where the problems happen, where two threads are able to go ahead and create new instances of this class. So in that case, what we can do is we can say something like synchronized. So if we make this synchronized, the idea is that thread 1 and 2 can't occupy a synchronized area at the same time. Only one thread can occupy a synchronized area at the same time, at a given point in time. And once it's done, only then are other threads allowed to access that area. But you see, the problem with this is, now this is very taxing in terms of performance. There's a massive performance overhead with synchronization, because every thread will wait for the next thread to get a copy of the instance, because this entire method is made synchronized. So is there something we can do that is better, that'll help with the performance issue? And yes, we do have a solution to that, and it's called double check locking, right? So what double check locking is we'll quickly code it. So instead of making this entire entire method synchronized, we will only synchronize a portion of it. Lazy and I'll say if okay, so there you go. That is double checked initialization. Pretty simple. Sorry, double check locking. So how is this working, you might ask? What happens is basically this helps the first few threads that come in to still only generate the instance once, but also to not maintain synchronized sessions over and over again. And how that's possible is, let's say thread 1 goes in and it says that okay, instance is equals to null, and thread 2 also comes here later. Thread 1 is now here and it's synchronized and it goes inside. Now thread 2 can't enter till it's done, and the synchronized area is all of this. So now thread 1 checks whether the instance is null, and yes, it is null, so it creates a new instance, and then it plays around until it gets the instance back. Now thread 2 is finally allowed to go inside the synchronized area because thread 1 has left that resource. Thread 2 checks if the instance is null. No, it is not. So it doesn't go ahead and do anything, but it does get the instance. And that's it. So there you go. That is double checked locking. It is used a lot in the industry, but there are other ways that are less, I guess, verbose in terms of the structure and the code. Now what we can do is I will go through one more implementation before we end this video, and that one I will create right now. And for that, again, I will make another copy of the basic singleton, paste it in here, and I'll call it the ISH singleton, and I'll tell you why now. Because what I'm going to be doing in this method is I will create an inner static helper class. So that's why I'm calling it the ISH singleton. So this is the next implementation of creating a singleton. Now this instance here will be a part of the inner static class, so we can get rid of it entirely. And I will create a new class. I'll make it private, static class, and let's call it the singleton helper. So that's our class there, and it will have another private field, private static IHS singleton, IHS ISH single. I'll call it instance as well, and new ISH singleton. Right, there we go. And now this get instance method will just return singleton helper dot instance. Now again, this is ThreadSafe 2 because there is eager initialization of this singleton, but the difference is now, even though this is eagerly initialized in the class, this instance is only created when we finally access this class, and more importantly access the inner class. So this is sort of not quite eager initialization, but at the same time, and it's also thread safe because it's only happening once in here. We've discussed this method. Again, this will work the same way when we go ahead and test it, so I'm not going to test it in the main class. But for now, I guess this will be all. There's one more implementation that we're going to have a look at, and I do recommend it. We'll get to that in the next video, but for now, this will be all. So I hope you enjoyed the videos. If you liked it, please subscribe and like this video. And let me know if I can help in any other way. And if I'm missing out on something, please let me know. I will be sure to add it in the in the upcoming videos. Thank you so much. This is Ashwin signing off.